Agriculture and farming is one of the most vital industries in the state of Louisiana, bringing $7.4 billion to Louisiana's economy. Agriculture and farming would not be possible without the help of farming equipment. Tractors play a major role in modern-day farming, especially on the large scale. In coastal areas, the undercarriages of tractors tend to have an issue with corrosion damage due to the saltwater presence. The most common material used in tractors' undercarriage is steel. This presents a problem because steel corrodes in the presence of salt water, and the undercarriages are closest to the ground, thus meaning they corrode the most on a tractor. In order to improve this issue, the steel must be modified to withstand corrosion from a high concentration of salt while also being able to support the weight of the tractor.
After evaluating possible solutions to improve the corrosion resistance of the material used to make an undercarriage within a tractor, we found that the best solution to improve corrosion resistance and to maintain strength of the undercarriage would be to modify the steel by using additional metals to strengthen it through alloying. After researching the effects different alloys have on steel, we found that chromium, phosphorus, and sulfur were all viable options that improved corrosion resistance while not sacrificing other mechanical properties and was at a reasonable price.
We have chosen chromium as our material to alloy with steel to improve corrosion, which is the main goal of this project. Through solid solution strengthening, the hardness and tensile strength can be improved. However, the ductility of our material would be lowered, which isn't ideal. The material needs to be able to handle the twists and turns that tractors' undercarriages require. We can make the steel more ductile through the process of annealing. Through this, we can also improve its ability to be machined. It will also allow the material to become more fatigue resistant and impact resistant, which is crucial to the undercarriage of a tractor. Chromium has the best corrosion resistance abilities for the price that it is offered at. Also, when steel is alloyed with chromium, the chromium forms a thin layer that was able to protect the metal from being exposed to salt water and other abrasive materials. While chromium may not be the cheapest option or the most expensive option, for the medium price it is offered at, there is a lot of improvement for corrosion resistance that is available.
After some research, it can be deduced that the steel will need to contain 17 to 27% of chromium to be considered a chromium steel. Since we are trying to utilize the corrosion resistance properties of chromium while not sacrificing ductility, the percentage of chromium should be in the range of 17% to 18% to achieve this. This would make our steel similar to that of an SS430. After the steel is alloyed with 17% chromium, the material will have a tensile strength of about 450 MPa. Next, the ductility must be increased. Therefore, the material will need to be annealed. We will anneal the sample by solution annealing. The chromium steel will be heated to about 815 to 845 degrees Celsius for at least 60 minutes. This process will austenize the chromium steel. We chose this temperature because this is the range of temperature that will cause the alloys to be successfully dissolved. Next, the chromium steel will be cooled in the furnace slowly at a temperature of around 600 degrees Celsius for about 90 minutes. We chose this temperature because it will reduce the internal stress in our material, and above any of this temperature, the material will still be going through phase changes, and we want to eliminate those. This temperature is low enough to allow the material to air cool without experiencing cracking. After cooling the substance in the furnace, the substance will cool in the air. This is done to prevent the material from becoming brittle. This is important since we want to keep the material corrosion resistant and keep it ductile. This is why we chose to air cool the substance and not quench it. Quenching it would present the possibility of forming a brittle material, and this would go against what we just did with annealing. The air cooling will allow the material to stabilize and become ductile again.
When adding chromium to a metal, the corrosion rate goes down. This is essential to our undercarriage because it is met with salt water and we need a high corrosion resistance. If the corrosion rate is too high, our undercarriage would corrode and cause the tractor to malfunction and break. We have chosen to use 17% of chromium because if we don't use enough, the corrosion resistance is too low. But if we use too much, it becomes too expensive to be realistic. After some research, we have found that when steel is alloyed, the temperature it must be annealed at is lower. Therefore, our annealing temperature also makes sense. Most of the elements that form ferrites when alloyed share properties with those that form carbides. This is known to increase hardness. Since we know that ductility and hardness typically have an inverse relationship, we knew our decision to anneal the structure to increase the size of the grains was reasonable.
Overall, by alloying the steel used in undercarriages of tractors with chromium, we can increase its corrosion resistance while also keeping the material strong and ductile through annealing. This will help the undercarriages of those tractors used in coastal Louisiana resist corrosion from the saltwater it will come into contact with, thus keeping our farming and agriculture here in the beautiful state of Louisiana strong and thriving.